So when we are looking at this first example, or this example to the left here, what we're going to do is we're going to rewrite our first fraction as it is, but in factored form. So I'm going to look for the factors. The two factors of -8 whose sum is -7 is -8 and +1. My denominator, I can remove a common factor q, leaving a q plus 1. I'm going to turn it into an invert and multiply problem. So I'm going to start here. My 2q minus 16 gets moved to the denominator. I factor out a q, leaving 2 times q minus 8. And then my denominator, q squared minus q, gets moved to the numerator. Factor out a q, leaving q minus 1. So here's my factored form. I've inverted and multiplied. Okay, so next I'm going to cancel any common factors here. So the q minus 8s cancel, the q's cancel, the q plus 1s cancel. Okay, and so I'm left with q minus 1 in my numerator all over 2. Okay, so here's my total simplified form. Okay, so when I go to look at my domain restrictions, I need to account for any canceled factors in the denominator and then any uncanceled factors from the numerator of this inverted fraction. Okay, so I'm going to start down here. I see that q can't be a 0. That's not apparent in the simplified form, so I include that. Q can't be a -1, also not apparent. And q can't be 8. So these are the three restrictions based on canceled factors from the denominators. Okay, but then at the same time, I have to look in the numerator of this inverted fraction. Any factors that do not cancel were originally in the denominators of their own fraction. So here, if q is 1, we don't necessarily see it, but if it comes back here, 1 squared minus 1 is 0. You cannot divide by 0. So that would make this original expression invalid or would be undefined. So I have to include 1 as an additional domain restriction as well. And so I'd have 4 different ones for this particular problem.